Greetings, friends, and welcome to today's distraction on a hot summer's day here at Brooker Creek Preserve Environmental Education Center. Today, we will meet the moths. And the moths, of course, are the unsung jewels of the nighttime. My name is James Stevenson. And like I said, I'm coming to you from the Brooker Creek Preserve Environmental Education Center in North Pinellas County, Tarpon Springs. If you haven't had a chance, please do visit. We're open every day of the year. Our trails are ready for hiking every single day of the year. And our exhibit hall is open Thursday through Sunday. So great place to bring the family, go for a hike, come inside, visit the exhibits, and check out Pinellas County's wildest place. On to the subject today of moths. What we will do today is we will look at what moths are. I mean, everyone probably thinks they know. Let's double check on that and come to some agreement about what moths are. We'll look at moth life and lifestyle, and we'll finish up with a selection of some of our moths that you might be likely to see around your place, wherever you live. And if you care to attract more, we'll give you some tips on how to do that as well. We'll look at some of the species and how we might best see them. Does that sound like a deal? Nice way to spend about an hour. We do have a couple of options for you to communicate with us today. We would love it if you would use the Q&A. I believe on your screen you should find a Q&A, little thought bubbles, speech bubbles. If you want to put your questions in there, that'd be great. I'll keep an eye on it throughout. We also have a chat. Julia is here, and Julia will be monitoring the chat. If you have any technical problems or questions, perhaps not for me, about Brooker Creek or anything like that, we'd be happy to monitor that as well. So let's, if you would like, tell me what you already know. I don't normally ask for input on these afternoon programs, but I know we get a lot of people with a lot that they would like to say, so I'd like to give you that opportunity. What do you think you already know? You can pop that in the Q&A. There's a couple of things that usually come up when I have a live in-person audience. They say things like, well, moths are nocturnal, active at night. They're kind of boring colors. Brown, boring, cryptically colored, camouflage colored, browns and grays. They eat clothes. I don't think that might be a different generation. I don't think we wear fibers anymore that are thought to be moth-eaten anymore, and they're covered in dust. These are some of the things that it seems like normal people normally say about moths. Let's see if anybody has any thoughts. Caterpillars. Yeah, there's a caterpillar part of the moth life cycle. Very good. Fuzzy antenna, mostly nocturnal. Very good. These kinds of things. Well, these more commonly known nocturnal, brown, gray, eating clothes and covered in dust. Hopefully today we're going to kind of dispel the fact that moths are nocturnal, or the fact that they're brown or gray, and so on. A couple of things we're going to explore. But let's start at the very beginning. What is a moth? It is a type of insect, and therefore it belongs to a huge group of animals, of course, the insects, all related to one another. All the same kind of animal, the insects. And this person who created this wonderful paper sculpture knows very well that insects, all of them, are in sections. They are in sections. three main sections: a head, a thorax, and an abdomen. And on the head, we've got the eyeballs and the antenna, so that's a sensory area of the body. The thorax is where the wings and the legs are attached, so that's kind of a motility part of the body. And the abdomen is the guts and the breathing and the reproduction and all that. So that's the basic insect body plan. And moths, being insects, adhere to that very body plan. Here's a bit more scientific, no shade on the artist who created the previous slide, but here's a bit more of an academic look at the three sections that insects are sectioned into. Yes, it is the same root: the head, the thorax, and the abdomen. So in that, moths fit in with all other insects. Zooming out from that, if I may, the insects themselves are part of a larger group of animals still called the arthropods. So technically, moths are a type of insect, which is a type of arthropod. So look at where we're nesting in taxonomy and classification and what's related to what. So they're part of this bigger thing. But the insects, you can see, being a group of these jointed critters with exoskeletons. Insects are the ones that can fly. Here we have a timeline of just the insects, that proto-insect, that proto-arthropod that had this wonderful body plan, three main parts. And on the second part, the thorax, there were wings. So the insects became extremely diverse. The very first insects are still pretty much unchanged today. Here's the first insect, and you can see an unbroken line that leads all the way up to the mayflies and dragonflies. Pretty much original design. These branching lines are situated in different places along a timeline from left to right, where we see insects becoming more and more specialized, more better adapted to different niches within various environments. And we end up with modern groups of insects that include, like, the roaches are a group. The earwigs, perhaps you've heard of them, with the giant pincher on the back. Beetles are a huge group. But if you look right here, there was an ancestor to a group that split into the beetles, the bees, the ants, the wasps, the flies, and the butterflies, the moths. And this ancestor bestowed on all those groups complete metamorphosis. That means going from an egg to a larva that bears very, very little resemblance to the adult. Complete metamorphosis, a complete change of form. These more proto-insects go through an incomplete metamorphosis, where the egg hatches into a smaller version of the adult. But complete metamorphosis belongs to just kind of these, if you will, more highly specialized groups. And the butterflies, and by extraction, the moths, fit into that category. And we've all heard the story of the metamorphosis. It's almost been done too many times. We get it. But for some reason, we just keep teaching it to our children over and over. I guess because it's so amazing. And, it is. It really is amazing. But it's not insanely unique to the butterflies. Do you see where I'm going? Complete metamorphosis is actually not uncommon in some very large groups of insects. Here's where it gets cool, I think. Controversial, could be. This is another one of those, what they're called cladograms, if you will, that show relationships between different groups. Now, we saw the relationships between the various arthropods. They all came from a common ancestor with an exoskeleton and diversified into all those different groups that included the spiders and the crabs, the insects, the millipedes. And then we saw the insects themselves and how they started with the mayflies and the dragonflies, and the complete metamorphosis led to, this is the same kind of graph. And if we look at just the group that includes the moths, here we have that proto-moth right there. This is the ancestor to all the moths that bestowed the characteristics of this group, this family of insects that are called the lepidopterans, which literally means the scaly wings. So the wings of this group of insects are covered in microscopic scales. They do come off like dust, but on high magnification, you'll see that they're very intricate, very deterministically placed scales. They're not just willy-nilly. It's not powdered sugar covering. It's not a powdered sugar donut. Get it? Very deliberately placed, patterned scales that can be various colors that lead to camouflage, display, and all over things. So the scaly winged insects have this common ancestor that's kind of represented today by some early diverging. There's still some of those ancient lepidopterans around, and we call them moths. And if you look down this graph, this goes in complexity from top to bottom. We have all these moths that diverged from these ancestors, and we have the modern groups of these moths represented over here. And then wait a minute. Then we've got this moth group that has a common ancestor that bestowed characteristics that set them apart into a subset that we call the butterflies. So the butterflies are just basically a weird kind of moth in the scheme of things. These are all the lepidopterans. And if you look, we have moths above and moths below. And then in the middle, we've got this weird group of moths that don't moth. They don't moth right. They don't moth like all the other moths. And so they get called something else, but technically they're related. And they have this common ancestor that bestow characteristics upon the rest. Sorry to beleaguer this, but I really do like to give y'all a foundation and not just jump into what's what. Moving on in complexity, we have this shared ancestor, this common ancestor that bestowed characteristics onto everything that became the butterflies. And then the rest of the group continued to diversify into modern groups of, again, what we would refer to as moths. So the butterflies are nested within a bigger scheme of things in organisms that we would refer to, based on morphology and habit, moths. Going through, we see some of the more butterfly-looking moths, a group called the underwings, the giant silk moths, and the sphinx moths. These are some of the groups that we'll look at today. Modern species of very early diverging moths we can see here around Central Florida. The micropterigids, I'm afraid, being small, being cryptically colored, being largely nocturnal, we don't have a lot of fun common names for a lot of moths. We do have this group that still retains a lot of the characteristics of that first ancestor to moths, including having a chewing mouth part instead of a slurping mouth part. Chewing is kind of a very basic way of processing food to bring into for digestion. It's what animals writ large do. You know, we eat with our mouths, animals. Moths are animals. These early diverging moths would chew parts of flowers, especially the very protein-rich parts of flowers, the pollen. So flowers are making all this protein-rich pollen, and this group of insects comes in and says, how about we take that instead of you using it for your reproductive cycle? We'll just have that. We'll just take that away and use it, and you'll. So here we had that going on. Well, not to be outdone, the plants started sticking their pollen to these fuzzy, scaly creatures that were coming to visit. And even though these scaly, fuzzy creatures that were coming to visit were there to eat the pollen, the plants started using them to carry pollen. So nice try, moth, but the flowers are going to press on. Those moths continued to chew on pollen. Other moths started finding that there were much more nutrient-dense rewards to be had at those same flowers in the form of nectar. And that takes us to the far end of the scale of specialization and diversity, to a group of moths called the sphinx moths. And the sphinx moths actually have that sucking tubular mouth. They do expressly feed on nectar, and they have formed some incredibly specialized relationships with some incredibly specialized plants. And this photograph of a sphinx moth pollinating the famous ghost orchid in the Fakahatchee strand proves this point. It could be that only this species of sphinx moth pollinates this species of orchid. This long spur that reaches down behind the flower with the nectar at the very tip is built to fit the key belonging to only one moth, that key being this extremely long proboscis that will reach down to the bottom, and that will force the moth to put its face as far into the flower as possible, where the flower will place the pollen. So from some kind of sloppy, chewy, early diverging moths that just stole nectar, all the way up to some very highly specialized relationships between a moth and a plant, there's diversity across this group known as the moths. Now, nocturnal. Most moths, these flying insects, including that common ancestor, had and have this nocturnal habit by and large. Now, what's that about? Why would it behoove a creature to be active at night? You can't see what you're doing. You can't find oftentimes what you're looking for. It's not typical business hours. So why be active at night? Well, you might have guessed that daytime is dangerous because it is business hours for everything else. So those lepidopterans that were active at night, there ended up being more of them at the end of the week. Get it? Because there's not so much danger at night. Then there was more at the end of the month. Then there was more at the end of the year. And millions of years go by, and that nocturnal habit is selected for. So that is really the best time to be around because it's really safe. We can diversify. We can find plenty to eat, and we can make a business day out of the night. But again, just like the flowers couldn't handle the moths eating the pollen without getting something for it, this group of mammals comes along that had a predilection to be active kind of at dusk. And there were these big winged, clumsy insects kind of beginning to wake up at dusk. And these little mammals would jump and grab them out of the air. And these little mammals would jump at them and, land back on their branch in the tree. And then they jump a little bit further. And then they got to where they could kind of glide. We're talking hundreds of thousands of years, and the ability, stretching some skin between fingers, ability to glide, which ended up becoming bats, who then were active predators of these nocturnal insects. So here we go. Now the moths are going to have to adapt to these new nighttime predators, keeping the nocturnal habit, not going to switch that. But now we need to adapt to these nighttime predators. Great. Well, solved, or at least addressed, by some of the larger silk moths. And in particular, which one has been studied, this Luna moth character, which if you're lucky enough to have seen, is not necessarily uncommon in our area. The Luna moth has these crazy tails that dangle off the back of its hind wings. Now, that couldn't help it fly. It would be nothing more than a burden. If you've ever seen the airplane that flies past the beach advertising someplace to go and drink or something, that plane's going really slow and you can hear the motor. It's struggling. It's got a lot of drag. But if you looked at this Luna moth the way that a bat looks at moths, do you know how that is? They throw sound at it. You know, bats throw sound and it bounces back. What they hear is an outline of what they're after. If you throw sound at this Luna moth, you're only going to be receiving back a little signature from these tails, these tail sections. So that's where the bat is going to focus its attention, because it's all it can see. And it'll grab those little extensions and get a mouthful of powdered sugar donut, and the rest of the moth can fly away. So it's give and take, adapt and change. And we can see this manifest in some modern species like this wonderful Luna moth. So what are they doing during the workday? Their workday being night. What are they up to? What kind of activities do you think animals do during the workday? Well, moths are no different. They need to eat. And those moths that actually do have mouths when they're adults, many don't. Many moths, many moths don't feed as adults. So if they're not feeding at night, if they don't have mouth parts, what else is there to do? Well, it's obvious. Animals, well, you can spend all of your time looking and bouncing around off of light bulbs. That doesn't seem like a very wise living, but it is a living, flying at lights. Using their specialized antenna to pick up various environmental stimuli, moths are navigating. They're navigating using chemicals in the air. They're navigating using wind, speed, and direction, which is detected by their feathery antenna. They're navigating using humidity. You might prefer a place that's a little bit more humid. That might be an easier place to breathe. It might be a nice place to hide. They're using these feathery antenna to detect environmental stimuli to get them where they want to go, which ultimately is reproduction. That's kind of the end all of existence for animals, right? So here we have an amorous pair of moths who have detected each other. And on the right, we have the female. On the left, we have the male. We can tell this thanks to the size and condition of their antenna. The male antenna being very, very large. The female antenna being not quite so. Really, the female doesn't need to work that hard to find a mate. All she has to do is just kind of sit still. This male is going to use his feathery antenna to pick up the signals that indicate the presence of a female, and he will find her. So the moth is the adult. The moth itself is the reproductive phase. Let's face it, that is the point of becoming an adult when you're an animal, is to reproduce, make more moths. So the moth is the adult phase. And when we go looking for moths, we're looking for these adult critters. We don't see smaller moths don't get bigger and bigger and grow up into grown-ups. When we see a moth, it is a fully formed adult. Moth is the adult. So what's the larva? What is the larva of a moth called? Y'all know this. It's called a caterpillar. Remember, we're lepidopterans. We might think that caterpillars only belong to butterflies. But remember, butterflies are just a weird kind of moth. It doesn't moth right. We still, all the lepidopterans have caterpillars, the larva of the adult, which will be, in time, the moth. And here we have a hornworm caterpillar, which is a moth larva, which is very unbeloved of many gardeners because they love a particular group of flowering plants in a very toxic family, including tobacco, including eggplant, including peppers, and especially tomatoes. In fact, there is a hornworm, which is what this caterpillar is referred to, called the tomato hornworm because of its propensity for attacking tomato plants. So caterpillars are the larvae of moths. And what do caterpillars do? Remember, this is the larva, so the caterpillars aren't involved or interested or capable of reproduction. So caterpillars only really have one job, and that's to eat. And eat. And eat and eat and eat and grow and eat and grow and eat and grow and eat and grow so that eventually it can become the adult to reproduce. So more eating. Here's a butterfly larva, still a caterpillar. Another inchworm, moth larva. Not a worm, it's a caterpillar. Eating, growing, eating, growing. That's the job of the caterpillar. Eating plants. Eating plants because they're easy to find, they don't run away. They can produce toxins that you can store in your body and make yourself repulsive, either as a larva or as an adult. But there's a group of moths, and thus their caterpillars in Hawaii, that are so tired of being picked on because, you know, caterpillars are big. Caterpillars are juicy. Caterpillars make excellent food for other creatures. And there's a group of moths in Hawaii, and the caterpillars have said, enough. Enough. I'm not going to spend my life eating plants and then getting picked off and fed to someone else's offspring. And this group has legs tipped in barbs, and they are predatory. This is the head of the caterpillar here, these two lobes, and these hooks are his barb-tipped legs. And here's the head of a giant termite and its body. This caterpillar has swung around and grabbed a giant termite and is going to eat it. Carnivorous caterpillars. Carnivorous, thus, by extension, moths. It can happen. The rest of the caterpillars, unfortunately, like I said, make fantastic food for everyone else's offspring. So in order for a healthy population of lepidopterans, moths, butterflies, etc., there have to be a lot of caterpillars produced every year. Everybody wants a caterpillar. They're nutrient dense, they're soft, they're slow, and you can shove them down your baby's throats without hurting them, without hurting your baby. You know? Let's do a little defense against this, shall we, saith the moths. Let's produce some defensive armature on our caterpillars, our most vulnerable phase, our larval phase. So many moth caterpillars have developed and produce defensive structures on their exterior to make them less appealing to be picked off and shoved down their offspring's throat. So many moth caterpillars have these defensive hairs, especially in spines on their outside. So these hairs, not to be messed with, not to be shoved down anyone's throat. In early spring, here in Central Florida, our inbox blows up every year. People wanting to get an identification on this thing, this fuzzy worm, this fuzzy caterpillar that's everywhere. Suddenly it's everywhere. It's terrifying. It's just the worst, most horrible thing anyone's ever seen every year. It's just a tussock moth caterpillar. It's just a caterpillar trying to make its living without being bothered. The hairs on this caterpillar are, in fact, irritating. If you looked at the hairs and each one of these elongated hairs, and these are little tufts of hairs. This is like, if you're familiar with a shaving brush, probably not, I believe a makeup brush. These are little tufts of very fine hairs, and the hairs have backward pointing barbs at the microscopic level that can break off and become quite irritating. So here is the irritating tussock moth that just wants to make its living and be left alone. So if you were to brush up against this thing, lay a hand down on it, heaven forbid, try and pick it up, put it in your mouth, you're going to be irritated as well. The tussock moth, when it's an adult, still just wants to be left alone. Perfectly camouflaged. I'm just going to pretend to be a leaf. Leave me alone. Cryptically colored, just trying to live its best life. There's a group of caterpillars called the slug caterpillars, of which the saddleback is a member. These are very slug-like in their movements. They're very gushy. The saddleback caterpillar, though, has not only irritating hairs, but actually venomous hairs. So these very strict spines on this caterpillar are packed with venom. And even brushing up against one of these will cause quite a lot of pain. Not damage, not hospital, but severe discomfort. It's a fascinating creature to watch. We do have them. There is no way to prevent having them unless you wanted to prevent having any living thing around your sphere of influence. Just something to be aware of, not to play with. And if you should, like I did, accidentally, unknowingly, and out of nowhere, brush up against one, you'll know it. And then you'll have a fun story to tell. Hey, I have been envenomated by a saddleback caterpillar, and you'll live. The adult, again, trying to be very cryptic, the saddleback adult is a rusty russet with kind of beefy forearms. The forearms of this saddleback caterpillar are very hairy, giving them kind of a Popeye the Sailor look. I'm making all kind of references that I bet most of you have never heard of. Another moth with some serious defense, the Eo moth. Again, these are venomous spines. These are do not mess with. So if you see a caterpillar that is armored, assume the worst. There's plenty of mimics. The Eo moth is a mimic of an owl. So if you disturb it as an adult, it's going to reveal these fake eye spots and try and convince you that you've just woken up an owl and you better leave. Eo moth. The puss caterpillar, another one of these that really is trying to be invisible. It looks like a wig. Not very invisible. I used to play with these when I was little. I would pick them up and pet them. I didn't realize that they were venomous, irritating, that they could have stung. They just didn't. So sometimes it's just luck. The flannel moth that emerges from the puss caterpillar is quite fuzzy. It's a very teddy bearish looking moth. The hornworm we mentioned before, scourge of the tomato tobacco growers, does turn into the sphinx moths. I understand that you can purchase hornworms at pet stores to feed reptile pets. I suppose they could be kept and grown into adults, and the adults would be sphinx or hawk moths with this very distinctive outline. We'll look at some moth families in just a bit. So caterpillars, larval moths, larval butterflies, insects, 3 legs. Nope, that's not true. 6 legs, 3 pair of legs. It's true of the caterpillars as well. The true legs, the 6 legs, are found up by the head. Here's a caterpillar, one of the hornworms, showing off his real insect legs that during metamorphosis will be reconfigured into, again, true legs. The rest of the body has these things called prolegs that aren't technically legs, but just kind of gushy outgrowths of the abdomen that have Velcro hooks on them and allow them to grab on. So they're not real legs. It's not like insects. Some insects have 10 legs when they're larvae, but they only have 6 legs when they're adults. Insects have 6 legs. But the larvae of the lepidopterans have these extras that they use in the larval form, and they're called prolegs. So some technical differences between butterflies and moths. One technical difference is not coloration and is not a nocturnal habit. Because here is a technical butterfly based on who it's related to, based on, remember, that common ancestor. This is an offspring of that ancestral butterfly. So this creature belongs within the butterflies, and yet it is boring colored and it's nocturnal. So this butterfly has gone back to a more mothy way of life. And here are some moths that are that don't share the common butterfly ancestor, true moths, that are colorful and they fly during the day. So that's not one of the main separations. Technically, moths have got big, thick bodies and fuzzy, hairy bodies. So you can see in this sweet bay silk moth, that big fat body. They have these feathery antennae, even the female, but mostly pronounced in the males. So this is a condition that did not belong to the proto-butterfly. That common ancestor of all butterflies did not have a big fat body and did not have feathery antennae, so its offspring don't. All the existing today. Also, moths. You ever seen these things hanging from the oak trees? These little caterpillars that belong to a type of moth. What are they hanging from? Not magic. They're hanging from silk. So caterpillar larvae make silken spit. And they use that silk for a variety of reasons. We know, perhaps you've heard of a silk cocoon. Perhaps you've heard of a silk drag line. Probably not. These leaf-rolling oak worms, caterpillars, use their silk to escape. They'll attach it to the tree and they'll just drop if danger presents itself. Some moth caterpillars take that silk and make cocoons. when it's time to pupate, when it's time to turn into the adult moth. And you might see discarded silken cocoons around. They dislodge themselves from the tree limbs that they're attached to. And you might find these rather large, smaller than about a third or a quarter of the size of a chicken egg, but the same kind of shape, this oval shape. It's a silken cocoon made by one of the large silk moths. We were on a walk one day and we found a disused silk cocoon that was being inhabited. This was wintertime. A green anole lizard had decided it would be just the best place in the world to get out of the cold wind on a November day. So that is not what the silk is there for, but hey, waste not, want not. Silk, of course, has been taken advantage of by humans. The silk moth is raised commercially. It is overfed, it is engorged with mulberry leaves, and it is encouraged to spin this silk cocoon out of its spit. And then we take the cocoon and we unwind it and make these very expensive articles of clothing. And this lady is really happy to be in her $300 bathrobe made of caterpillar spit. Inside the cocoon, of course, the pupation is happening. Magic, complete metamorphosis, going from a worm to a flying thing. Incredible, absolutely incredible. The inside is liquefying. And then all of those amino acids and proteins and everything are reconfigured into the adult, ready to fly and mate. Let's look at some local moths and some ways that you might observe them a little bit more closely. If you did want more, and I'm sure you will, I can only bestow upon you what I know as an enthusiastic botanist, right? Who has been concentrating on studying moths from a horticultural perspective. So moths as pollinators, moths as potential pests, but certainly being surrounded by this group. You can visit nationalmothweek.org. This is Moth Week. This is why we're producing today's presentation. Last Friday, we all got together with a public event in the evening, and we looked for and were successful in catching moths and identifying them. If you go to nationalmothweek.org, which we don't get any money from, I don't even think you can pay for anything on this site. It's a free site. It's an informational. You could download this key to some silhouettes of the selection of moth families. So it's kind of useful as a quick reference. And I'm just going to remind you, like I said in the beginning, so many moths are cryptically colored, nocturnal, unsung. A lot of them don't have common names. A lot of them only go by their scientific names. Many moths are undescribed to science because they're unsung. So that's why we're singing about them today. Anyway, this handout is available at nationalmothweek.org, and it basically gives a very generalized outline of what some groups of moths look like when they're resting. So if you were to attract moths, this is what they would be looking like when they're not flying. So we have twirler moths and fungus moths, very, very small. The leaf rollers and the pyralids, also small. The carambid moths with their kind of elongated, very elongated wings. The clearwing borers, I'm not familiar with. Slug moths, we saw the saddleback, one of the slug moths, again with his beefy forearms. The plume moths cut a very distinctive silhouette. We'll look at them in a second. They just look like the letter T. The geometrid moths, we decided that the geometry of the geometrid moths is a parallelogram. That's this one right here. I'm not familiar with the tent and forest caterpillar moths. I do have a caterpillar moth slide in here of just one. The owlet moths are quite designer. They're very often highly patterned, and that's indicated here. The tussock moths, remember the tussock moth caterpillar with the little bundles that freak people out in the spring? They too tend to have rather fuzzy forearms that are apparent. Those are his feathery antenna there, and just below are these kind of fuzzy forearms. The underwing moths, these are a larger group of, I'm sorry, the individuals themselves are large. They could be mistaken for butterflies. They're oftentimes disturbed during the day, and you'll see one go by, and you'll find out in a couple of slides later why they're called underwings. The largest are the saturnids or the silk moths. The sphingids are the sphinx moths, and the tiger moths, like the owlet moths, very similar in appearance, also very highly patterned. So just a look at some of the subgroups of moths, some of the more common ones that you can see around your sphere of influence, should you be trying to attract them or not. Here's one of those plume moths. Like I said, it looks like the letter T. These wings are comedy, but fully functional. And there are actually 2 wings tucked in here and 2 wings tucked in here. Very slender, long legs, slender body. But again, it is going to be lacking the club at the tip of the antenna, which is more characteristic of the butterflies. This could be the same species as the one we saw before, or it could be a different one. Whoops. The plume moths are one of those groups where they're kind of, all the ones that are brown and tan are kind of mashed together into a group called the grape plume moths. Distinctive pale colored plume moth. Apologies for the poor photography. My camera was more interested in the glass in the window for some reason. We know what tribe this one belongs to. This is one of the morning glory plume moths. Again, with that distinctive T shape. And here's another member of that same group, the morning glory. I promise the pictures will get better. I just wanted to show you some cool plume moths. Plume moths, distinctive. Here's one of the carambids that I was telling you about with those more elongated. Here it is being a classically elongated, very distinctive patterning on this melonworm moth. And look what's happening back here. This male, whoops, now I'm confused. This moth, this gender non-specific moth, is producing out of its other end a plume of hairs that are saturated with pheromones. So moths can not only detect the presence of pheromones in incredibly small quantities from the air using their feathery antennas, they can also produce them. So this is where those pheromones are being emanated from. And these hairs will then retract when this individual is not preparing them. A melonworm moth. The tulip tree beauty is a geometrid. So this is one of the parallelogram moths. The tulip tree beauty here has some very intricate scalloping on the wings. You might even be able to see some of those scales, individual scales, like feathering. That allows them to be very silent when they fly, could help in avoiding detection by bats who use sound, right? Cryptically colored to be perfectly camouflaged at rest during the day on the bark of perhaps a tulip tree, which this moth is named after. The classic geometrid is the emerald, and there are many species of emerald moth. So if you see a green parallelogram, you're very safe in assuming that is an emerald. You'd be safe in saying, an emerald. And everyone's going to be looking for an expensive ring. But you're only looking for moths because you're cool. Maple span worm. Guess what the larval food is for this caterpillar. And this geometrid, this parallelogram, doing a very good job of camouflaging itself as a leaf during the day. So this moth can rest with its wings open. Some moths rest with wings folded across their back. Some rest with their wings open. Here's an example of a geometrid moth. They rest with wings open. And with this decoration down the center between down the center of the wings, looking very much like the mid vein of a leaf. So this imitating a dead leaf. I quite like this grapevine looper, another geometrid. What I'd like you to try and notice here is that this moth's abdomen is looped up over its head, facing forward. So up from behind, over the head, and facing forward. And I assume it is going to have the ability to produce something rather noxious from its tail end to kind of lead the way with some offense if anything tries to bother it. That's what I imagine of the grapevine looper. A small Arabid moth, a lichen moth. Guess what the larvae of these things eat? Very brightly black and orange colored. Yes, the answer is lichen. Another small, very distinctive, charismatic moth is nocturnal, large eyes, hoping to catch some of that faded light reflected off surfaces at night. Excuse me, the tiger moths are those, remember, those are the folded wing moths that can often be very highly patterned. Here's a pale tiger moth doing just that, being both those things, being highly patterned and pale. The pale tiger moth, again, you can see the weft and weave of the sheet that it's clinging to. That might help you with the size of this, probably only 2 centimeters long. The underwing moths, which on that handout from National Moth Week, you can just get an idea of what's happening. The hind wings, which are covered when this moth is at rest with its wings folded over its back, are revealed when the moth is disturbed. And this flash of bright red and black is supposed to be a warning signal. Go away and leave me alone. Classic underwing to be invisible until disturbed, and then those underwings take on the job of being hopefully very offensive, or at least shocking enough to send a potential predator running. This moth, covered in hairs and scales, is, as you can see, the rosy maple moth. This moth, in my opinion, deserves plushy status. This is a moth that deserves to be considered a charismatic insect that could be a gateway insect into maybe moth conservation. We've got the butterflies down, and we've got the tragic sob story of the monarchs getting people motivated to conserve the monarchs. Maybe we could use something like the charming rosy maple moth to call attention to the disastrous fate of many of our moths. Maybe? Is that asking too much? Probably. But in the very least, we could get a plushie made out of a rosy maple moth, and that would be really cute. One of the saturnid, one of the silk moths, these are the big ones. This is the regal moth. And the regal moth would be resting with its wings outstretched were it not for having been disturbed. We disturbed it. It was on the screen. We got excited. Somebody yelled, I don't know who, oh my God, a regal moth. And it changed its posture. Same too with the spiny oakworm. Another one of the saturnids, another one of the larger silk moths that make those significant silken cocoons with the twice stabbed wings, with those white spots on it. Our lovely Luna moth, one of our largest, its wingspan is probably as wide as your hand, maybe 12 centimeters. There you have those tails. We mentioned the function of these tails. This is a female Luna moth. We can see that although the antennae are feathered, they're not humongous like the males have. We actually did capture this female. She laid eggs. We were able to go through her life cycle with her offspring for months. The eggs continued to hatch. They fed on sweet gum leaves. The caterpillars formed silk cocoons. They pupated inside. A new generation of the Luna moths emerged. It was quite fun. Moths make great pets. The Io moth is what emerges once that horrible, spiny, venomous caterpillar emerges, that green, spiny caterpillar. Again, let's not kill caterpillars. Let's let them do their thing. Let's keep our hands off, leave them alone. If the bird gets them, good for the bird. But we need to tolerate a level of caterpillarness in our gardens, because the saturnid moths are out there and they need to go through their entire life cycle, including the silkworm known as the sweet bay silkworm, which I didn't even know existed until we had this visitor to our boardwalks here at Brooker Creek, where a lot of sweet bay grows. Handy that, isn't it? So we need to conserve our wetlands. We need to conserve areas where sweet bay grows in swamps. People drain swamps so they can build houses. We need areas like Brooker Creek where we can still support the larva of the sweet bay silkworm. Interesting cocoon made from the false burnet moth. Now, the moth itself, not much to look at, hardly anything at all. In fact, invisible. Here on the right, it is facing downwards, black. Invisible at night, forget it, gone. Talk about minding its own business. But look at the cocoon that it spun. It's silk into more substantial and unwoven threads, more like a cage where it pupated inside. That's the pupal skin there. But this cage looks as though it's made of gold filigree. Absolutely amazing. Intricate. A real treasure to find. The green marvel, one of the noctuid moths, very highly patterned, sounding very much like a superhero, being a more of a turquoisey green, not an emerald green like the emerald, but the green marvel is often confused with a moth about the same size, also with a slightly green hue, called the Hebrew. Is it critically important that you can tell the difference between these two if you're just looking at moths? No, not necessarily. Know that there are these two. Know that there are ways to tell them apart. The Hebrew, the markings are a little bit more curvilinear. I suppose the meaning of the name is that to someone, the markings on the wings of the Hebrew looked something like perhaps the Hebrew alphabet. A carambid moth with, again, those elongated wings is a parusta moth, coffee loving. So the larva will roll up coffee leaves. Perhaps you have some coffee leaves that are rolled up right now. Inside, the caterpillar is going to be pupating and emerging into this incredibly small. If you grow matchstick plant or phyla or frog fruit, this entire moth fits on the head of a single frog fruit. But it's cute, it's colorful, it's day flying, and it feeds. It is nectivorous, so it does have functional mouth parts. Pretending to be a cigar, doing a very good job. This is one of those caterpillar moths I was telling you. I'm not all that familiar with the tent and caterpillar moths. This is considered one of the caterpillar moths, I suppose, as an adult, because it has this tubular shape. What this moth is actually mimicking is a broken twig. What a fantastic job. Look, that is dead flat right there. His little head's tucked up under there, looking down, but this dead, doing a great job. Absolutely 100% overlooked. All the more reason moths, they're kind of doing it to themselves. They're kind of overlooked because they're so camouflaged. A carambid moth with no common name, but highly decorative. Designer, as a friend would say. I don't even know how to pronounce his genus. This was just a nice find on an early morning on a window at the back here at Brooker Creek. And we'll finish up with the Sphinx moths. Remember, kind of representing the highest degree of specialization, the highest degree of evolution. Evolution doesn't work towards an ideal. That's not how evolution works. But in the realm of being very specialized and highly derived, and being derived from the most number of divisions of that cladogram, this one has the most ancestors back to that original, the Sphinx moths or the hawk moths. That's the same group. This is the banded Sphinx moth, doing a very good job of kind of optical confusion. So all these lines going in different directions at rest on a patterned surface like a tree bark, tree trunk is what I was looking for, would certainly confuse any potential predator, as this was resting during the day. Another of the Sphinx moths, the hydrangea Sphinx moth, again with those confusing linear divisions against a very green background. So again, to our eyes, perhaps this would be a good gateway insect to get friends involved in conservation. Look, here's something that won't bite or sting or do anything like that. Nor will the Virginia creeper Sphinx. This one, again, looking very much like a dead leaf. Moths are very good at that. But you see the classic delta wing pattern of the Sphinx moths. It's perhaps you can see what makes these related to one another. Their common ancestor of all the Sphinx moths had this distinctive delta pattern on its wings. So I would love to tell you more and more moths, but I'm going to have to call it quits. Let's finish up with how to observe moths on your own. It can be as simple as leaving the light on the back porch. That's perfectly acceptable and effective. If you want to take it to the level that we take it, we set up what are called moth traps. Now, they don't physically enclose or entrap moths. It just concentrates moths and other night-flying nocturnal insects to the same place by reflecting light off of a white surface. So the least sophisticated would be an incandescent light bulb and an old white sheet. Perfectly acceptable, perfectly functional. Here we have a bit more of a refined setup because we intentionally and deliberately were going for attracting the highest number and diversity as possible. We have this set up with a mercury vapor light and a black light together. This is at one of our moth nights. All the excitement is around this blur. Down at the bottom is where we had a sweet bay silk moth come crashing in. But you can see on this sheet, we've got lots of other visitors, beetles, all kinds of things Moths are certainly not the only nocturnal insect out there. And incandescent light, very effective. If you can find them anymore, it's a wavelength that seems to be attractive to, for heaven knows what reason. We don't have any idea. We don't have any idea why moths are attracted to light or any of these other nocturnal insects. They just are. And we take advantage of it. I mean, there's all kind of theories about it, but we're not sure. Incandescents produce a wavelength that draws in the moths. What about the bug lights? They don't. Bug lights actually kind of work. Those yellow lights, they don't draw in maybe half or maybe half as many moths. So there really is some efficacy, but they seem to draw an extra number of other groups of insects. The earwigs and the true bugs seem to love yellow lights. So, I mean, bug light could mean two things: keep the bugs away or bring, in particular, two larger groups of insects in, the true bugs down at the bottom, or the dermapterans, the skin wings, the earwigs. That might be your thing. Real moth enthusiasts use a combination of black light, which is strong ultraviolet, which is strong, don't you dare stare at it. So UV, black light, very affordable, very available. Consider putting a black light out on your back porch. See what happens. It's going to do that much better than an incandescent. The number one is this mercury vapor lamp. And again, we don't know what it is about these wavelengths that is so irresistible to moths and other nocturnal insects. We don't know what it is, but it works. And so we take advantage of that. Mercury lamps are available over the counter, as it were. They do require some special handling, which is very important for you to be aware of and for you to pay attention to before you just go out and jump into mercury vapor world. Mercury lamps get extremely hot and extremely bright. So no staring at moth lights if you're going to produce a moth night of your own, although we highly encourage you to do this. It's a great way to observe and then just leave the apparatus, turn the lights off, let the insects disperse the next morning or later that night. Very low impact, very hands-off, but a great way to learn a lot about a lot of insects in a short amount of time in a small space. I'm done. That's enough. I do hope to go over your questions now. If you have anything pressing that you would like to put into the Q&A, or I'll also check the chat. Do reach out if you have questions, comments, complaints, or concerns going forward. Here's my email address: first initial J, last name Stevenson. String that all together at pinellas.gov. Now let's take a look at some of the questions. So in Central Florida, the question is, here in Central Florida, what's the best time of year to put out sheets and lights to see moths? Actually, you could do that year round. You really can. The very best time is now, midsummer. Unfortunately, it's when the sun goes down, of course, the latest. So the activity is pushed. The peak activity begins around 11 p.m. So here's what you do. You sleep late, set up your moth business around 8 o'clock. Around 9 o'clock, stuff starts kicking off. By 10 o'clock, you've got your arrivals. By 11 o'clock, it's really happening. By 1 and 2 a.m., you're losing your mind. We do monthly moth nights beginning in May and running through October. We do take the middle of the winter because you are going to get the least diversity in number during the winter months, but it's never zero, never zero. Yeah, light pollution. Yeah, there's all kinds of threats. There's no end of threats to moths. There's no end of threats to all insects, environmental, habitat destruction, everything. The change in the climate, the heating of the heating. A lot of our species aren't going to like this, and they're going to find their latitude that they're used to, and that's going to be further north. So it could very well be, we've already seen distributions of species creeping northward because they're going to try and get to their temperature range that they're used to. And now that we're so much hotter, so many more days of the year, that is outside what these species are used to. So anything that we can do for conservation, anything that we can do to make their lives better for them, especially the easiest thing is being tolerant of the caterpillars, accepting of the moths, and educating friends and relatives. Right. Okay. Another difference that, the cocoon is a construction made by moths and not the butterflies. The butterflies just go straight to chrysalis. Choose my tomatoes at a chewing mouth. Yeah. And so Donna's wondering about the business, the tomato hornworms that are after the tomatoes. It's not the moth that's chewing on your tomato plants, it's the caterpillar. It's likely that you'll find an adult around your tomato plants. You know what it's doing? Laying eggs. So that when the eggs hatch, those caterpillars have access to your lovely, undoubtedly lovely tomato plants. The answer there is to every year plan on growing, as long as you have the space, and it doesn't take that much, an extra couple of tomato plants that are sacrificial. You can't get ahead of it, but what you can do is find these big suckers and just relocate them to your sacrificial tomato plants. The species that we covered today, when I said everything after I said meet your neighbors, the species are found hyperlocally, Pinellas County. Those were all found right here in Pinellas County. And with very few exceptions, the photographs of individuals, mostly not named in the beginning of the presentation, might be individuals that weren't found here. But yeah, the majority of today's species were found right here in Central Florida. How long do moths live? That's a great question. They are adults, so the caterpillars can live for weeks and weeks and weeks. Some caterpillars, when they do go into their cocoon, they might do that in the autumn and then spend months in a state of dormancy in their cocoon, still alive, and then emerge as an adult in the spring. So that elongates the lifespan of a particular moth species. If you're talking about just the adult phase, that would depend on whether or not the moth species has the ability to feed as an adult. So the sphinx moths can feed. They have the proboscis and they feed on nectar. They can live for several weeks. The moths that do not feed, like the giant silk moths, the Luna moths, they're only around for a matter of days, believe it or not, despite their size, all that effort that they put into, they only live for a matter of days, maybe a week. And during that week, of course, they'll get married and try and lay, the female is going to try and lay as many hundreds and hundreds and hundreds of eggs as possible. And do hummingbirds, oh, Christy, I apologize. This last bit of today's presentation on the sphinx moths, that most highly specialized with the most branches on its family tree, the hummingbird moth is a type of sphinx moth. It's a clear wing sphinx moth. So yes, they do live in Pinellas. We see them a lot around our Walter's viburnum. The Walter's viburnum is a plant that is native to Florida, and it makes a great landscape plant. and is the larval food source for the hummingbird moth. If you're not familiar with this moth, it is a day-flying moth, and it hovers just like a hummingbird, and it visits flowers as it hovers. So it looks very much in size and shape like a hummingbird. Great question and a great reminder. We're always looking for ways to improve our presentations. So well done. Will we find Luna moths in Utah? Yes, Luna moths are found across the United States. So good luck with that. And cabbage moths. Do we have cabbage moths here? Yes, we do. And they are butterflies. But they're moths, right? Technically, they're moths. Yes, we do have them here. They are imported. They came with the crops. So they love those brassica crops. I'm looking in the Q&A. Do we have anything in the Q&A that I need to? Yes, the irritating hairs of the caterpillars, irritating to humans. Of course, children with their thinner skin can be more irritated than others. Yes, eel moths are very painful. Appreciate the very kind comments. And we're always looking for ways to improve. So if any have questions, comments, or complaints going forward, we'll be certainly welcome to entertain those. I've enjoyed spending the afternoon with you here. Certainly lots and lots more to learn. So keep your eyes, if you're not a member or a friend, or if you haven't joined or followed Brooker Creek Preserve, as soon as we're done here, go to Facebook, join that, member, friend us, do all those things so you can find out about more programming coming up, especially Moth Nights, beginning again in September. So until next time, thank you very much for joining us today, and we hope you have a wonderful rest of your day and a wonderful rest of your summer.